Hi everyone! In the last lesson, we reviewed what is the mole, and we learned how Avogadro's number relates to the mole. So in this lesson, let's review molar mass, and how does molar mass relate to the mole that we learned about. Now, molar mass is important because we're going to be using it for here on out in advanced chemistry. Before we get to that, we need to remember how to count atoms. Hopefully you remember that an element symbol is going to tell you the type of elements in a compound. And the subscripts, which are the numbers found in the lower right-hand side of each element symbol, is going to tell you the number of atoms. Now, a couple things to remember about subscripts is if there is no subscript, then that means that there is an understood one atom for that particular element. The second thing that usually people get stuck on or make mistakes on are what if there are parentheses. If there are parentheses that surround a group of atoms, this indicates that the number of all atoms inside those parentheses or brackets have to be multiplied by the subscript on the outside. Here we have 4 examples of us counting atoms. I'm going to do 2, and then I'm going to let you do 2 on your own. So the first one that we're going to do together is lithium sulfate. It has 3 elements: lithium, sulfur, and oxygen. Looking at the subscript, we can see that lithium has 2 and oxygen has 4. Here, sulfur does not have a subscript, so that is going to be an understood 1. Down here, let's do an example with parentheses. We have 3 elements: iron, carbon, and oxygen. Here, my subscript tells me 2 iron, but here I have parentheses with a number on the outside. Remember, whenever you have parentheses in math, you distribute it to both numbers, or in this case, both elements. So 3 times 1 carbon gives me 3 carbon. And 3 times 3 oxygen, 3 times 3 is 9 oxygen. So I want you to go ahead and try these 2 on the right, and let's see if we get the same answer. Now that you've tried it, hopefully you get the following. For ammonium chloride, there is nitrogen, hydrogen, and chlorine atoms. There are 1 nitrogen atom, 4 hydrogen, and 1 chlorine. Down here for ammonium phosphate, hopefully you saw that there are 4 types of atoms: nitrogen, hydrogen, phosphorus, and oxygen. And we're going to have parentheses. Make sure you distributed this 3 to both, so 3 times 1 gives me 3 nitrogen. 3 times 4 gives me 12 hydrogen. We have 1 phosphorus and 4 oxygen. Hopefully you did well on those. If you didn't, come see me. I can give you some more practice. Moving on from that, this is going to bring in the idea of molar mass. Now, a mole is always going to be that same number, 6.02 times 10 to the 23rd. Remember, we learned this as Avogadro's number. However, a mole of a sample actually has different masses. For example, a mole of 1 carbon atom will have a mass of 12.011, whereas magnesium is about twice that mass at about 24.305. These numbers are also known as the atomic weight of elements, given in AMUs. These are equal to the mass of 1 mole of that element. So hydrogen, hopefully you remember last year, always got 1.0079. Oxygen is another one most people had memorized from last year, 15.999. The molar mass true definition is the mass in grams for every 1 mole of a substance. It's measured in units grams per mole, in other words, written grams per mol. In order to determine molar mass, we have to know where to find atomic masses of each element. These are going to be located on the periodic table. For example, periodic table, your atomic mass is going to be this number right here on the bottom. Most of the time, they will have a decimal. So magnesium, again, is 24.305. So how do I find molar mass of a compound? To calculate the molar mass of a compound, first we need to find the grams of each element for 1 mole of that compound and then add the masses of each of those elements up. This method can be used and applied to any kind of compound, whether it is molecular or ionic. To find the mass of a compound, though, you do need to know that formula or have some way to find what that formula is going to be. So let's do an example problem. It says the decomposition of hydrogen peroxide provides sufficient energy to launch a rocket, and I want to find the molar mass of hydrogen peroxide. Well, hydrogen peroxide's molecular formula is H2O2. What you need to do is figure out what elements you have. So I have hydrogen and oxygen. Here I have 2 hydrogen, 2 oxygen. The next thing you would do is you would have to look on the periodic table. So hydrogen's on the periodic table. It's very hard to read right now, but it's 1.0079. And that gives me 2.0158. And then oxygen, if you go look at the periodic table, it's a little hard to see. 15.999. When you multiply that, you get 31.998. And then you take these two values and you add them together. You guys got really good at this last year, but I just want to go back over so you guys are familiar in case you guys had questions. So my molar mass of my hydrogen peroxide is 34.0138. So I want you to see if you can try to do this one. Find the molar mass of ammonium carbonate. This one's going to be a little bit harder, but you have had practice with these last year. Let's see if you guys can do it. Now let's see if you guys got the correct answer. Here we have 4 elements: nitrogen, hydrogen, carbon, and oxygen. You have 2 nitrogen, 8 hydrogen, 1 carbon, and 3 oxygen. So when you multiply these by their respective values, for example, nitrogen is going to be 14.007, hydrogen's 1.0079, carbon is going to be 12.011, and oxygen is 15.999. When you equal these out, you get 28, about 8, of course your 12, and then your 47. When you add those all up, the molar mass of ammonium carbonate is 26.0852. And this is going to be, again, written in grams per mole. From there, last year we learned how to use molar mass to convert between mass and moles. Here, molar mass is always given in grams, and moles usually gets the number 1 in front of it. Here, 1 mole for whatever mass in grams that you found that we've just did practice on. So here we're going to learn how to interconvert between mass and moles, in other words, convert from moles to grams. It's going to tell us calculate the mass in grams of 0.433 moles of calcium nitrate, and it gives us the formula CaNO3 2. First thing, with any conversion, you always start with what you're given. Here in the problem, I'm given 0.433 moles. And I am given that of calcium nitrate. Again, if you want to cancel moles, moles has to go opposite, so moles will go on the bottom, and the number 1 is attached to moles. Okay. Then what you would do is you would find the molar mass of this. When you find the molar mass of that, you're going to see that it is 164.086 grams. And when you go to calculate that, your answer is going to be 71.049238. Again, we've been working with sig figs, so we want to round this to the correct number of sig figs. Here you have 3 sig figs, so your answer would also have 3 sig figs. So 71.0 grams of calcium nitrate. A good question here is you would not use this number in here because remember, conversion factors do not count towards your final number. Here, I want you to try this one on your own and let's see what you get. If you were to do this problem, again, you start with what you know, 6.33 moles. To cancel moles, it would go on the bottom, and then you would have to find your molar mass. Hopefully you guys got 84.0059 grams. When you would go to find this, you would get 531.757347, but you can only have 3 sig figs, so 5, 3, and this 7 rounds that 1 up to a 2, so 532. Don't forget your unit, grams of what? Of sodium bicarbonate. How did you guys do? Now we're going to go backwards. Instead of calculating moles, instead of calculating grams, we're going to calculate moles now. So here, this example problem says calculate the number of moles of glucose in 5.380 grams of glucose. So again, you always start with what you're given. Here, I'm given 5.380 grams. Now that I want to get rid of grams, it's going to have to go on the bottom. So I'm going to find the molar mass of glucose, which is about 180.1548 for every 1 mole. Here, that number's on the bottom, so we need to divide those two numbers. And when you divide it, you get 0.029863265. Again, sig figs matter. Here I have 1, 2, 3, 4 sig figs. That 0 counts because it's at the end, and there is a decimal. So here I need 4 sig figs. Remember, this 0 right here does not count because it's a leading 0. So 2, 9, 8, 6. There's my 4 sig figs. Make sure you remember your unit, moles, and then what compound? Glucose, C6H12O6. And here, this is the last one I'm going to have you try for this lesson. Try to find the moles of sodium bicarbonate. You've already found the molar mass of this, so hopefully you kept it jotted down. So let's see how you did. So let's make sure we get the right answer. Again, hopefully you guys started with what you know, 508.7 grams. When you find the molar mass of that, 84.0059 for every 1 mole. You would divide those two numbers, and hopefully you got 6.055527052. Here you can have 4 sig figs, so we have to make sure my answer can have 4 sig figs. So 6.05, and then this 5, this 5 will round that one up to a 6. So here we have 4 sig figs. Don't forget your unit, moles of what compound? Sodium bicarbonate. Okay. So how did you guys do? That's the end of today's lesson. Let me know if you have any questions. If you need more extra practice problems, I'm more than welcome to give you. If you want to walk through it one-on-one with me, I'm also more than happy to do that as well. And otherwise I hope you guys have a good day.